Hello everyone, welcome to this next series on the previous year's questions from complex analysis and which appeared in the exam, GATE exam. So here we are taking a 1 mark question. This is a really simple question. So the question is, if f is the given function from C to C and it is given to be analytic except for a simple pole at z is equal to 0. So we are given at z is equal to 0 there is a simple pole. That means the pole has order 1. So simple pole means it has order 1, right? And the another function g is given to be analytic over the whole complex plane. Then they are asking what is the value of this thing. So this is res z tending to 0 means the residue of this particular function when z goes to 0 divided by the residue of f of z when z goes to 0. So here, in order to calculate the corresponding residues, we need to see a result corresponding to this residue. So the result says, if we have an analytic function given inside and on a simple closed curve C, so we have some closed curve, say this is our C curve, and the function on this boundary and within this region, this is analytic, except there is some point A, say this is point A, there this is not analytic, and it is a pole of order m, right? So in that case we can calculate the residue of the function f of z at the point A by using this formula, and the formula is we can calculate it using this formula. Limit z goes to A, and A is the given pole, and if m is the order, so we have to divide by m minus 1 factorial and then take the m minus 1th derivative of this thing. So let us do the same for the present case. We are to calculate this thing, residue of z going to 0, fz into gz divided by residue when z goes to 0 of the function fz, right? So this is what we need to calculate. So now if we apply this thing onto this, we know gz is given to be analytic function, and fz is also analytic except at z is equal to 0, where it has simple pole. That means the order for that pole is 1. So we have m is equal to 1 and z is equal to 0 for f of z, and there is no problem in calculating g of z. So residue of this g of z won't make a difference over here, right? So just using this formula, what we can have, we do have limit z goes to 0, m is 1, so we have 0 factorial over here, right? And then we'll take the 0 derivative. 0 derivative means we are not operating any kind of differentiation onto this function. Z minus 0 raised to power m. M is 1 for the present case, and the function, the above function would be f of z, g of z. And similarly, the same thing will do for the denominator. So it would be limit z goes to 0 and then 1 upon 0 factorial, right? Because here again m is 1 and z is 0, and we won't perform any kind of differentiation, and the same thing, but now instead of f of z into dz, we only have f of z. So now this thing is 1 and we are not operating anything onto this, so we can simply write this thing as limit z goes to 0, right? Z into fz into gz divided by limit z goes to 0, z into f of z. Now when you substitute the limits onto this and these functions, we know g is analytic, so we can directly substitute the limit. So we'd have g of 0, and then we'll be left with limit z goes to infinity, z into fz divided by limit z goes to 0, z into f of z. So now this term cancels with this term, so we are only left with g of 0. So our final answer while evaluating this whole expression turns out to be g of 0. So this is our answer. So here option A is the correct option. Well, that is it for this video. Thank you for watching.